All right.
Go ahead. Thanks, Leonard.
All right. Thank you for inviting me to the crucial Python session. I'm going to talk about a library I created called Beautiful Soup, a library which is celebrating its 10th birthday this month. It was first standalone release was on May 20th, 2004, and I'm just going to show you what it's for and how you can use it today. The problem Beautiful Soup was designed to solve is HTML. HTML is a really popular data format. For a lot of really interesting data, it is the only format in which the data is available. And it would be really great to have a programmatic access to the data. Unfortunately, pretty much every file in this format is invalid. Nobody who created files in these formats were anticipating that anyone would ever want programmatic access to this data, and the content of an HTML file is encoded in an encoding that only sometimes has any relationship to anything you've ever heard about what the encoding of the file is. Beautiful Soup solves these problems. It will convert a byte string into Unicode no matter what, and usually it will guess the encoding correctly. It will convert an HTML document into a Python data structure no matter what. And it gives you a Python-style interface for navigating and searching the data structure. I'm just going to show Beautiful Soup philosophy is your time is more valuable than the computer's time. Beautiful Soup is not the fastest parser in the world. It sits on top of another parser, so it's obviously slower than that parser. But in general, Beautiful Soup is much easier to program than other parsers. So here's some HTML. This is all this code, and the sample HTML is taken directly from the Beautiful Soup documentation. And it's a normal HTML file with a head tag and a body tag and a p tag with CSS class and some links that have IDs and CSS classes. You run this into Beautiful Soup and it turns it into a nested data structure like this. It's effectively a nested dictionary. And the structure of the dictionary corresponds to the structure of the HTML document as near as the parser can figure out what that structure is. Here's a little bit of code. The first bit of code just loads a string into Beautiful Soup, and then if you want to get the title tag, you do soup.title. You do member access, or attribute access actually. If you want to get the string inside the title, it's soup.title.string. If you want to get the parent tag of the title tag, you use the parent attribute. If you want to get the name of that tag, it's the name attribute. And then we've also got a bunch of methods, which I'm only showing two here, for locating the specific tag or tags that you want. For finding one tag, it's called find. For finding more than one tag, it's called find all. And you can search for all the A tags, as we are in the first example. You can search for all the tags where a certain attribute has a certain value, as we are on the second example. You can search by CSS class. And again, I'm going to refer you to the documentation for all the details. But basically, if you can write a little bit of Python that says yes or no, whether or not you want something to match, then you can pass it in here and it will match it. Beautiful Soup, because it's been around for 10 years, is really popular. I did a GitHub search and I got about 21,000 code results. These are files that import Beautiful Soup. These aren't necessarily individual projects that use it, but that gives you a picture of how widely it's used. My favorite high-profile usage is this piece of installation art in the New York Times building on 42nd Street. These are little screens. One of the people standing in front of these screens is Mark Hansen, one of the artists who is here at Columbia. These screens take data from the New York Times database, which it comes in XML format. It parses them using Beautiful Soup, and then it presents them in various interesting ways. This is called movable type, and it's in the sort of public lobby, so you can go in and take a look and watch the news flow by. And this is a recent testimonial that Suna sent me, which I think captures why Beautiful Soup is popular, even though it is not the fastest way to do something. I believe it is the fastest way to get started doing something with HTML where you can immediately see the results. This person was just learning to program, and Beautiful Soup fit in with what else they were learning about Python and turned the world of HTML, which is completely different, into a world of data structures and Python methods that they could program to get the data that they wanted. Beautiful Soup is just the tip of the iceberg. There's a whole lot of other tech that Beautiful Soup depends on that you might want to use instead of Beautiful Soup, or that you might want to use with Beautiful Soup. And just for reference, so you can look these things up later, I'm just going to go down a really quick list of other stuff you might be interested in if this talk is interesting to you. There's a library called Cardet and a C version of the library called C Cardet, which Beautiful Soup will use to detect the encoding of a byte string. There are parsers that Beautiful Soup sits on top of. By default, it will use the parser that comes with the Python standard library, but there's two others called HTML5lib, which tries to parse HTML the same way a web browser would, and LXML, which is an XML parser that's really, really fast. If you want Beautiful Soup to be a little bit faster, you can install LXML and tell Beautiful Soup to use that parser. If you really want speed, you can get rid of Beautiful Soup. You can just use LXML, and you can learn how to construct XPath expressions that will get you the data you want. I personally find XPath expressions, once they get beyond a certain complexity, to be really difficult to understand. But for simple stuff, LXML plus XPath can really churn through a lot of HTML or XML. You've got HTML files. Where does the HTML come from? It comes from the web. Requests is the best Python library for making HTTP requests. You can just give it a URL and it will give you the data. You can customize the HTTP request if you need to do something special. It's got a really great interface. Requests will download a single web page. What if you want to get an entire website? There's a library called Scrapey, which will crawl an entire website, download all of the HTML, and let you process it. And then finally, what if you need not just the HTML that comes with the page when you make the request, but something that happens, let's say, when you load the page in a web browser and some JavaScript runs. You need to look at the status of the page after the JavaScript is run, or you need to interact with a control on the page that runs some JavaScript when you click on it. In that case, the tool to use is Selenium. There's a Python binding for Selenium, and it will let you load up a real browser, any browser you want, and drive it around, send it from one URL to another, find links, click on them, look at the HTML, whatever you want to do. Selenium will give you all of the power and all of the complexity of a real web browser. And my closing thought I would like to leave you with is, not just when dealing with parsing HTML, but in general, your time is more valuable than the computer's time. It's better to finish something, go out to dinner, leave the computer running overnight, than to stay up all night to get a really well-tuned program that at 4 in the morning gives you the result it would have done if you had just left the crappy version of the program running all night. Thank you. If there are any questions, I'm happy to talk. I